Hello, third grade math friends. Today's lesson is going to cover finding equal fractions or equivalent fractions. Use the high vocabulary word. And using math models to support our equal fractions. And in this case, the models that we're going to use are number lines. This lesson is covering standard 3 NF2A, and the mathematical practices that's going to be addressed is 4. Modeling with mathematics. So let's begin. Hopefully you've gained some background knowledge about the process of why fractions are equivalent. If you look at the visual model, you can see that I have 1/2. But even using the visual models, I can see what 1/2 is equal to. If I should make this 1/2 and I make 4 equal sections, that 1/2 now becomes 2/4. 2/4 and 1/2 are equal. But the big question is, why? Why does this work? Why can I equalize fractions so easily? It's very simple. Fractions can be shown to be equal in 2 different ways. I can go from large to small by multiplying. And then I can go from small to large by dividing. To go from large to small, I take a value and I multiply by it. One times 5, 2 times 5. And notice I use the same values. 1 times 5 gives me 5. 2 times 5 gives me 10. So therefore, 1/2 is equivalent to 5/10. Now to go from small to large, I'll divide. And in this case, five divided by 5, 10 divided by 5. And 5 divided by 5 gives me one equal group. And 10 divided by 5 gives me two equal groups of 5. So therefore, 5/10 is equal to 1/2. Small to large, large to small. The big thing that you have to understand is, as you are using your multiplication division skills, when you multiply and you divide, notice the values are the same. Whenever you are multiplying or dividing, make sure that you divide or multiply the numerator and the denominator by the same digit. Another way to prove that a value is true is to cross-reference. Cross-reference means you take the values and you multiply. In this case, 1 times 10, 2 times 5. 1 times 10 has a product of 10. 2 times 5 has a product of 10. And because 10 equals 10, they're equal. These fractions are equal. It's proven. But suppose I said 1/2 is equal to 3/10. Well, cross-reference to prove it. 2 and 3, 1 and 10. One times 10 has a product of 10. 2 times 3 has a product of 6. Uh-oh. 10 is not equal to 6. So therefore, not equal. So where do number lines come into this? I think it's important for me to let you know that math students always want to support their math thinking with multiple models. Using a number line will allow that to happen. Let me show you an example. I am going to find an equivalent fraction to 3/4. In this case, I'm going to go from large to small. So I'm going to multiply. I'm going to take a value, and in this case, I'm going to use 2. Same value. 3 times 2 is 6. 4 times 2 is 8. 3/4 ultimately is equivalent to 6/8. But why is this true? One model shows why it's true, but my support, I'm going to use a number line. I'm going to label my number line 0, and ultimately this is 1. But in this case, I'm going to show fourths. I know that 1 is equal to 4/4. I'm going to make my intervals of fourths. So I'm going to need to say 1, 2, and 3. 1/4, 2/4, 3/4. Let me make that different. Let me make that a different color. 3/4. But what about eighths? Well, let me look at this. So let me make this 8/8 because 8/8 is also 1. So on the same number line, let me make my eighths too. 1/8, 2/8. Let me do a little better. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. So then when I count them, one eighths, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So as you can see, 3/4 and 6/8 are on the same part on my number line. They're equal. So now I have different models. I'm labeling, and my answer is complete. Let's try another. This time, I'm going to go from small to large. I'm going to say 4/8. 4/8. I want to find something that's equivalent to 4/8, but I want to make it larger. So what am I going to divide by? Well, I'm going to divide by 2. Well, actually, no. I'm going to divide by 4. Make it simple. See if I can divide by 4. 4 divided by 4 gives me 1. 8 divided by 4 gives me 2. 4/8 is equal to 1/2. I'm going to prove it. Oops. But this time, I'm going to use cross-referencing. 4/8 equal 1/2. And if it's true, they're going to be equal. 1 times 8 equals 8. 4 times 2 equals 8. 8 equals 8. It's valid. It's true. But I'm going to use a number line to show the values. On this one, I'm going to show eighths. 8/8 and 8/8 is equal to 1. So let me make it happen. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. And in this case, 4/8 is located here. Let me go ahead and plot it. Halves. 2 halves is equal to 1. Plot my points. There are 2 parts to 1/2. 1/2, 2 halves. So as you can see with my model, 1/2 is equal to 4/8, or 4/8 is equal to 1/2. They're equal. And ladies and gentlemen, our lesson today showed how to form equivalent fractions using multiplication and division, we also validated why fractions are equivalent using cross-referencing. And we used models or number lines in this case to support our thinking. Hopefully this helps. Thank you.